Welcome to The Explainer. Today we're diving into how researchers are teaching AI to do more than just make cool-looking video clips. They're teaching it to think like a director and actually tell a cinematic story. So you've almost certainly seen some of the mind-blowing videos coming out of AI models like Sora, right? You give them a simple text prompt and they spit out these hyper-realistic, sometimes totally fantastical scenes that just look absolutely incredible. But here's the thing. There's a huge difference between making a beautiful, silent 10-second clip and crafting an entire movie with a story that makes sense, characters you care about, and real emotion. That's a massive leap. So let's get into the fundamental challenge here. What's really stopping an AI from becoming the next great filmmaker? Well, researchers have a name for it, the semantic gap. Think of it this way. An AI is a brilliant pixel pusher. It can create amazing images, for sure, but it doesn't really get the story behind those pixels, you know? It doesn't understand the subtext or the emotion. It's like knowing all the words in the dictionary, but not understanding poetry. To really direct a film, an AI has to nail three big things. First, it's got to understand all the context hidden in just a few lines of dialogue. Second, it needs to know the actual language of filmmaking. We're talking camera angles, shot composition, the whole deal. And finally, it needs creative reasoning, that crucial ability to show, not just tell. So a team of researchers at Tencent decided to look past the latest, greatest tech. And they found their big breakthrough not in a new algorithm, but in some timeless wisdom from a true legend of the silver screen. So let's see how a classic piece of filmmaking advice completely reframes this entire problem. And this quote from Alfred Hitchcock, well, it was a total light bulb moment for the researchers. They realized the missing piece for AI wasn't a better video generator at all. It was the script. It was always the script. So they just flipped the entire process on its head. Instead of asking the AI to just make a video from a vague idea, they decided to first teach it how to think like a screenwriter and a director to create a detailed shot-by-shot blueprint before a single frame was ever generated. Now, to pull this off, they built a framework of 3 specialized AIs all working together. You can really think of it as a complete virtual film crew. First up, you've got the scripter agent. This is your writer. Its one and only job is to take raw dialogue and turn it into a proper, detailed cinematic script. We're talking camera moves, character actions, scene descriptions, everything. Then, the director agent takes that script and acts as the on-set director. It's the one that orchestrates the actual video models, telling them exactly what to create to make sure every single scene flows together and makes sense. And finally, hey, every production needs a critic, right? The critic agent reviews everything. It checks the script for quality and coherence, and then it looks at the final video to see if it actually lives up to the script's vision. So you see how they all work together in this really elegant pipeline? It starts with just a few lines of dialogue. The scripter agent turns that into a detailed plan. The director agent executes that plan, and the critic agent provides quality control from start to finish. Okay, so the theory sounds amazing. It makes a ton of sense on paper. But the real question is, did this AI film crew actually make better videos? So the first test was the script itself. They had human film experts actually read and evaluate the scripts from the scripter agent, and the results were pretty impressive. They scored around a 4 out of 5 across the board on things like narrative coherence and just being a complete usable script. Now, here's where it gets really interesting. They took these high-quality AI-generated scripts and fed them into all the top video models out there. And guess what? The performance of every single model got way better. A better plan simply led to a better final product. To be specific, the videos were up to 0.4 points more faithful to the story they were supposed to be telling. Now, trust me, in the world of AI benchmarks, that is a massive jump in quality. But the research also uncovered this fascinating little quirk. It turns out that today's top video AIs are kind of like flashy blockbuster directors. They just love to add extra visual spectacle. You know, dramatic lighting, explosions, anything to make the shot look cool. But sometimes they do it at the expense of the specific emotional notes that were actually in the script. So what does all of this mean for the future of entertainment, for filmmaking, and really for human creativity itself? This framework from Tencent is a pretty major breakthrough. I mean, it's really the first solution that successfully bridges that semantic gap we talked about, turning a simple idea like dialogue into a complex, coherent, and maybe even an emotionally resonant story. The big takeaway here is the shift in perspective. We're moving beyond thinking of AI as just a tool for making short, flashy clips. This points to a future where AI could be a genuine creative collaborator, a partner that actually understands the language of film. And that leaves us with a pretty provocative final thought. As these AI systems get better and better at the actual art of storytelling, what does that mean for the role of the human director? Will we be co-directing with AIs? Or could the next great cinematic visionary actually be a machine? It's a question we might see answered a lot sooner than we think. So OpenAI, the team that brought us ChatGPT, has just dropped something new. And no, it's not about writing poems or emails this time. This is a tool aimed at one of the most important areas of human progress, scientific research. It's called Prism, and its whole mission is to fundamentally change and, speed up how science itself actually gets done. And look, this quote from their announcement really hits home. It's not just some feel-good line. It highlights the stakes. I mean, think about it. Scientific progress is what drives societal progress. So if we can make science go faster, we can make everything go faster. But there's a big problem, a major roadblock. There's this massive disconnect in the world of science. On one hand, you've got these incredible, mind-bending discoveries. The stuff that pushes the absolute frontiers of what we know. But on the other hand, the day-to-day work, the writing, the citing, the formatting is often stuck in the dark ages, using these clunky, totally disconnected tools. It basically puts a speed limit on breakthroughs. All right, let's really dig into this everyday struggle, because the issue isn't a shortage of brilliant ideas. It's about all this hidden friction in the process that's just slowing everything down. And, the problem is something you can almost feel. Just picture a scientist trying to write a groundbreaking paper. They're not in some sleek, focused workspace. Nope. They're juggling a word processor for drafting, a PDF viewer for their sources, a totally separate reference manager, probably a LaTeX compiler, which is like a whole coding language for papers with complex math, and then another chat window for AI help. Every single time they switch, their focus just shatters. This workflow here, it just lays it all out, doesn't it? You draft a little in one window, then, bam, you gotta stop, switch over, and search for a paper. Then you're jumping into a citation manager. Then you're spending way, way too long just fighting with the formatting. And if you want some AI help, you have to copy and paste everything into a different tool, losing all the important context of your work. It is so inefficient, and it just drains your creative energy. So that's the mess we're in. And this is where OpenAI's solution, Prism, comes into the picture. It's built from the ground up to be an AI-native workspace, specifically designed to get rid of all that friction we were just talking about. Okay, so what is Prism, really? The key is right here in the definition. This is not just another text editor. It's an integrated environment where the AI, and we're talking about OpenAI's latest model, GPT-5.2, is woven directly into the workspace. It's not some separate button you click on. It's part of the fabric of the tool. And get this isn't some brand new thing they just whipped up overnight. OpenAI actually went out and acquired a company called Crixit, which already had a mature, solid platform for scientific writing. So they've taken that strong foundation and then supercharged it with their most advanced AI. That's a huge head start. All right, so we've got the problem and we've got the solution. Now let's get into the how. How does Prism actually create a smarter, more unified workflow for these researchers? This is the big question Prism is built to answer. We're not talking about an AI that understands a single paragraph you paste into a chat box. We're talking about an AI that understands the entire paper, the structure, the equations, the references, the figures, all of it, all at the same time. And that deep understanding unlocks some absolutely incredible stuff. You can draft and revise with an AI that sees the whole picture. You can search for literature on sites like Archive without ever leaving your document. The AI can analyze your equations and your citations for you. And this one is just wild. You can take a photo of a whiteboard diagram and Prism will turn it into clean LaTeX code. And you're doing all of this while collaborating with your team in real time. And that real-time collaboration, oh man, this is huge. It completely ends the nightmare of emailing different versions of a paper back and forth. You know what I'm talking about? Files named manuscript_v4_final_final_Jane's edits, that whole thing, gone.
Everybody works in the same document, and every change is reflected instantly for the entire team. Okay, let's zoom out for a second, because this is so much more than just a better text editor. The vision here is much, much bigger. It's about transforming the very infrastructure of how science gets done. So what's the broader impact here?
For starters, check this out. Unlimited collaborators, now that might just sound like a number, but think about what that really means. It signals a huge commitment to large-scale open science. It means massive international research teams, maybe tackling things like climate change, can all work together seamlessly, without worrying about seat licenses or access levels. And then there's the price tag. It's zero, absolutely free. Making Prism free to use is, you could argue, its most significant feature. It just rips away a huge barrier to entry. Researchers at smaller universities in developing countries or just someone early in their career, they now have access to a top-tier, world-class tool. It really does level the playing field. You know, OpenAI makes this really powerful comparison here. They suggest that just like AI tools, think GitHub Copilot, completely transformed software development back in 2025, a similar profound shift is about to kick off for science in 2026. Let that quote sink in for a second. By slashing all that friction in the day-to-day work, you're not just making a scientist's life a little easier, you're freeing up countless hours of collective brainpower to focus on what actually matters: discovery. It's a huge step toward accelerating science itself. And this really brings us to the final and maybe the most important question of all. If we can fundamentally speed up the engine of scientific progress, if we can make it more efficient, more collaborative, and more accessible for everyone, what happens next? What new medicines, what new sustainable technologies, what new understandings of our universe are now just a little bit closer? That is the future that Prism is hoping to unlock. In the world of AI, it feels like the race has always been about building the biggest, baddest model. But what if the entire game just changed? Over the past year, something really fascinating has happened in China's open source AI community. There's been this huge strategic shift away from just chasing model performance to building something way more ambitious. We're talking entire ecosystems. Today, we're going to break down that new playbook. And really, it all boils down to this one question. How on earth did a single event, just one model release, trigger a complete and total rethink of a national AI strategy? That's what we're here to unpack. So the catalyst for all of this was an event back in January 2024, which people are now calling the DeepSeek moment. And look, this wasn't just another model getting dropped online. It was a seismic event. It was proof, real, tangible proof, that top-tier AI reasoning wasn't some secret magic locked away in a few closed labs. Nope. It could be open, it could be reproduced, and it could be systematically engineered by anyone. That one moment set off the 5 major strategic shifts we're about to walk through. All right, first up, the first huge shift was the almost overnight, near unanimous adoption of a totally different kind of architecture, mixture of experts, or MOE for short. Think about it like this. The old way was to build one single, gigantic model, kind of like an overworked generalist who's trying to be an expert in everything at once. The new strategy, mixture of experts, is completely different. It's like building a team of specialists. When a problem comes in, the system is smart enough to route it to only the most relevant experts. The result? It's just way more efficient and way more adaptable. And this is so crucial. The whole goal shifted. It wasn't about chasing the absolute best performance, no matter the cost. Instead, the focus pivoted to something much more practical: building models that could run sustainably, be deployed flexibly, and be updated continuously. It's all about finding that sweet spot, that perfect balance between costs and performance for how things actually work in the real world. Okay, so the second strategy builds right on top of that first one. It's about expanding way beyond just text in what you can only really call the modality rush. Seriously, after the DeepSeek moment, the floodgates just blew open. All of a sudden, open source AI wasn't just about large language models anymore. We saw this absolute explosion of new capabilities all happening in parallel. We're talking text to video, 3D model generation, creating realistic speech, building AI agents, you name it. Companies like Tencent with their Hunyan video model and StepFun with their awesome audio models all jumped into the fray, each trying to create the next DeepSeek moment in their own domain. And this is where it gets really interesting. They weren't just dropping the finished model, the weights. They were open sourcing the entire engineering stack.
The tools, the datasets, the workflows, the whole shebang. This was never about just one-off breakthroughs. It was about building a solid foundation of reusable, system-level capabilities that everyone could build on top of. Now for our third strategy, and this one might seem a little counterintuitive at first glance. It's the surprising and, frankly, total dominance of small models. The playbook they're running here is just fascinating. It's this teacher-student model. So first, a company will build an absolutely massive, super powerful MoE model. That's the teacher. Its job is to set the high watermark for what's even possible. But then they use this clever process called distillation to basically transfer all that knowledge down into a whole family of much smaller, much more practical student models. So why bother? Well, because for 99% of real-world business uses, these smaller models are just way more practical. They're easier to run on your own hardware, they're way cheaper to fine-tune for a specific job, and they're so much simpler to plug into the systems you already have. I mean, just look at the popularity of models like Qwen 1.5 0.5b. It is a staggering number of derivative models built from it, which just proves the point. Okay, strategy number 4 takes us from the nitty-gritty tech stuff over to the legal side of things. But trust me, this is just as critical. It's all about making permissive licenses the default setting. This was such a simple change, but it had a profound impact. After that DeepSeek moment, the Apache 2.0 license basically became the de facto standard for pretty much every major open-source AI release coming out of China. So why is that such a big deal? Well, because when you use a standard, well-understood license like Apache 2.0, you remove a massive amount of friction. It makes it incredibly easy and legally safe for businesses to just grab these open models and start building commercial products with them. No more legal headaches, no more weird custom licenses to parse. It just massively speeds up the journey from a cool open-source project to a real system that people can actually use. And that brings us to our fifth and final strategic pillar. And honestly, this one is a fundamental reversal of how things used to be done. It's the big shift to a hardware-first stack. Just look at this evolution here. The old way was model first. It was basically, here are the model weights, have fun, good luck getting them to work. The new hardware-first approach is the complete opposite. A release today doesn't just include the weights, it comes with a full, reproducible pipeline that is optimized to run like a dream on specific domestic hardware right from day one. This quote right here just perfectly captures the essence of this whole shift. The goal isn't just to make the code downloadable anymore. The real goal is to make sure that developers can actually run these incredibly powerful models and run them reliably and efficiently on the hardware they actually have. And this is not just some theory, right? It is happening right now across the entire stack. For inference, actually running the model, you've got day zero support for domestic chips from Huawei and Cambricon. For training, actually building the models, Baidu has documented using thousands of its own Kunlun accelerators. And for serving, getting the model's answers out to users, you have companies like Moonshot AI actually open sourcing their production-grade infrastructure. It's a complete end-to-end hardware-aware strategy. So, okay, let's just take a step back. When you put all 5 of these strategies together, mixture of experts, the modality rush, small models, permissive licenses, and a hardware-first stack, what does it all add up to? Well, it signals that we're on a completely new battleground now. A comment I saw from the community just sums it up perfectly. What's being open-sourced isn't a single model anymore. It's the blueprint for an entire AI ecosystem, from the data and architecture all the way down to the hardware optimizations and the legal framework. And that right there brings us to the ultimate takeaway. The very nature of the competition has fundamentally changed. It's no longer the simple contest to see who has the model with the highest score on a benchmark. The real competition now is about who can design the most cohesive, the most efficient, and the most practical end-to-end system. Which leaves us with a pretty critical question for the future of AI, doesn't it? As individual models become more and more like commodities, maybe the new frontier isn't about having the best model at all, but about having the best system. And in this next phase of the global AI race, that might be the only thing that really matters. So, here's a question for you. Can an AI actually get a joke? I mean, really get it. Not just, repeat the words back, but understand the feeling, the timing, the whole shared experience that makes something funny or, iconic. Well, today we're going to dive into exactly that, how researchers are putting AI to the test on one of the most human things out there, the meme. Oh yeah, you know this scene, right? You can practically hear the voice, feel the tone, that epic feeling behind just 4 words. I bet you've even used it yourself, maybe to jokingly guard your lunch in the office fridge or something. But here's the thing, what does an AI see when it looks at this? And way more importantly, what does it actually understand?
Okay, so let's really dig into this, because this is the heart of the mystery, right? An AI can listen to this and transcribe the words, "you shall not pass," perfectly, no problem. But does it get the defiance, the drama, all the thousands of ways we've woven it into our culture? You know? That's the billion-dollar question if we ever want to create AI that can truly connect with us. So, to figure this all out, you're going to need something more than just a standard test. You basically need a cultural IQ test for machines. A way to measure not just what they're seeing on the surface, but what they actually get deep down.
And this right here, this lays out the gap perfectly. Look, AI has gotten absolutely brilliant at the surface level stuff. Identifying objects in a picture, transcribing speech, that's perception. But it's the deeper meaning where it really struggles. Think about it. The sarcasm in someone's voice, the cultural baggage of a certain song, why a silly sound effect makes us all crack up. That's true understanding.
So, the question is, how do you even test for that? Well, a team of researchers decided to tackle this head on. They set out to build the ultimate exam, one designed specifically to see if an AI can navigate the messy, complex world of our culture. And here it is. It's called the AVMeme Exam. Now, the name might sound a little playful, but don't let that fool you. This is a seriously sophisticated tool. It's a benchmark built from the ground up to find out if today's most advanced AIs can really, truly resonate with us on a human level. And we're not just talking about a handful of viral clips here. No, no. This is a massive, carefully curated collection of over 1,000 iconic audio-visual memes. I mean, they've got everything from Beethoven to Nyan Cat, spanning different languages, different countries, and even different historical eras. It's the whole shebang. But what's really key here are the types of questions they're asking. It's not just, hey, what did that person say? Just look at this breakdown. A massive chunk is about contextual inference and world knowledge. This test is specifically designed to measure deep understanding, not just basic surface-level recognition. Another huge piece of this puzzle is that the exam is super audio-centric. The sound is absolutely crucial. And we're not just talking about clean, crisp speech. It includes stuff from noisy backgrounds, full-on songs, instrumental music, and even just pure sound effects. All those things that carry a ton of meaning, often without a single word being spoken. And get this, the exam is truly global in scope. Because let's be real, memes aren't just an English language thing. So it's got content from Chinese, Japanese, Korean, and a whole bunch more. Plus, there's a big slice of just non-language sounds that pretty much cross all cultural borders. This thing is a true test of multicultural intelligence. Okay, so we've got this massive, super diverse exam. Now, how do you actually grade an AI on something like this? Well, it's not just a simple pass-fail. The way they score it is designed to figure out just how deep the AI's thinking really goes. It basically works on 3 different levels. So, level 1 is what you'd call surface comprehension. Can the AI just identify what was said or heard? Pretty basic stuff. Then you get to level 2, deeper thinking. This is where it gets trickier. Can it figure out the emotion, the context, the humor? And then the final boss, level 3, cultural knowledge. Does it actually know how and why we, as people, use this meme out in the real world? All right, so this is the moment of truth. The researchers took the most advanced AIs out there, everything from open source models to the big giants like Gemini 3 Pro, and put them through this test. And the results, well, they revealed this really fascinating and super consistent pattern of strengths and, maybe more importantly, some pretty glaring weaknesses. And this is the core finding, right here, clear as day. So on language analysis, that's that first basic level of understanding, the top AIs are scoring around 85%. I mean, that's pretty impressive. But look what happens when you move up to the deeper levels. Contextual inference takes a hit, and then for world knowledge, understanding the cultural meaning, the performance just craters to around 50%. It's like they know the words, but they just don't know the world. So that gap between knowing words and knowing the world was already huge. But then the researchers found an even bigger blind spot. It turns out the one thing that really stumped these AIs the most was sound, and specifically, sounds that didn't have a nice, neat text transcript to go along with them. So check this out.
when a meme clip actually had people speaking in it, the top models were pretty solid, right around 80% accuracy. They can process the language, analyze the content, and spit out a pretty decent answer. But just watch what happens when you take those words away. The accuracy just plummets. For clips that were only sound effects or instrumental music, even the very best AIs really struggled, with their performance dropping below 65%. What this shows is this critical dependency they have on text. It's like, without words to guide them, AIs are just lost in this sea of what to them is culturally meaningless noise. So how does all this stack up against, us? Well, the top commercial model, Gemini 3 Pro, does really well, actually. But the best open source model is lagging pretty far behind. And here's the real kicker. Humans, even when they've never seen the meme before, can still score around 65%. That's better than a lot of these models. Our built-in cultural context just gives us this massive head start. Okay, so why does any of this actually matter? I mean, they're just memes, right? Well, it goes so much deeper than that. This isn't just about a humor gap. The researchers actually call it an empathy gap, and that is a major roadblock for the future of AI. Because when you get right down to it, this test isn't really about memes at all. It's a stand-in for understanding human communication in all its messy, contextual, emotional glory. Look, if we ever want AI to be a true partner, a genuinely helpful assistant, a tutor, a companion, it has to understand not just what we say, but what we actually mean.
And, the researchers who built this whole thing, they put it perfectly. They said, understanding audiovisual signals is not merely about perceiving isolated sounds or images, but about connecting them to how people interpret, feel about, and use them within context and culture. Which, leaves us with this one big final question. We can build AIs that process data faster than we can even think. But what's it going to take to build one that can truly share a moment with us? An AI that doesn't just analyze a joke, but one that can genuinely laugh along because it understands why it's funny. Now that's the next frontier.